Yes.
Okay.
If you move into the okay, now it's okay.
Okay,
Please.
so good morning to everybody. This presentation has been divided into parts. The first part is related to the advanced diagnostic methods that can be used for the evaluation of cleaning treatments. So I will show you some example of the activities we are developing in the last few years in the development of new system for cleaning paintings and other cultural objects. But the focus will be mainly put on the type of information that can be achieved and the techniques that can be used to evaluate the performance of the methods. The second part of this lecture will be held by my colleague, Giorgia Sciutto, and we will be mainly focused on the use of advanced spectroscopic methods coupled with data processing system. So the problem of cleaning polychrome surfaces is a challenging topic since it is quite dangerous operation, since it is aimed to remove selectively a very thin layer without affecting the above painting layer. And the traditional system based on the use of organic solvents applied mainly with cotton swabs present some problem related to the toxicity of the solvents that are used, but also to the problem that the use of these solvents may create on the above painting layer, like swelling, leaching, and leading to a not selective removal of the external layer. In the last few years, a lot of attention has been devoted toward the development of alternative solutions that take into consideration not only the safety of the objects, but also the safety of the operator, since in the past very dangerous materials were used affecting the health of restorers, and also the impact of this product toward the environment. And recently, a call has been launched in the frame of the new Horizon Europe calls related to the development of sustainable solutions in restoration. However, it is very important to evaluate the effectiveness of these new methods. And to this extent, ad hoc analytical protocol based on the use of non-invasive and micro-invasive techniques is quite important in order to evaluate if these new green solutions are effective towards the cleaning treatment. I will show you some example with the focus on the type of techniques that can be used based on the activity we are developing since a few years in this field, based on testing of new system, mainly gels materials, which are obtained with non-toxic, biorenewable and biodegradable substances. These materials are based on the use of two different supporting materials, PHB, polyhydroxybutyrate, which is obtained from bacteria, that is used to disperse green solvent like ethyl lactate, gamma valerolactone, and dimethyl carbonate, or biodiesel, for the removal of different kinds of coatings, terpenic resin, acrylic compounds, and waxes for biodiesel. Then some example will refer to a new advanced composite materials obtained with electrospoon material and polyhydroxybutyrate gel. And also a second type of gels have been obtained using agar as a supporting material with some particular solvents, which are called DES, deep eutectic solvent, which are polars but don't contain water. And this kind of material has been used for the removal of proteinaceous coatings. So just some reference to the material that has been used for the cleaning. This is the appearance of the PHB gel, so it's quite compact and very handy to be used. And this is the appearance of the agar gel with deep eutectic solvent. This gel may be applied both on real case study and has been widely tested on MOCKUPS, let to act for a few minutes, and then after the removal, the swelled coatings layer is removed with a dry cotton swab. An advanced system that we have tested is the composite system, obtained embedding in a certain way the gel into 2 sheets of electrospoon tissues. And in this way, a very handy system is obtained, which has shown very, very interesting properties. This is the appearance of this tissue on which the gel system is embedded. But focusing the attention more on the analytical part and on the kind of information which are important to evaluate the cleaning treatment, the first information that is needed to be achieved is for sure the removal efficacy. This can be easily obtained as a first evaluation by just recording images with a photographic system of imaging method, employing either visible or UV light in order to see the effectiveness of the treatment directly on the work of art. But if we want to have more sensitive evaluation of the efficacy of the removal, we can take some sample and observe the disappearance or the reduction in the varnish thickness before and after the treatment. Taking sample for cross-section and limitation, of course, when we refer to real work of art, since we have to limit the sampling and the fragments are very small, so the information that is achieved with this approach may be not so significant. So, to better understand the performance of the system, molecular techniques which provide information about the composition of the external layer of the work of art can be used. For instance, we can use portable FTIR spectroscopy. This is an example of the use of this technique before and after treating Tanofesta painting on paper with the DES agar gel in order to remove a proteinaceous coating. And from the spectra, we can notice that the signal related to this coating, to this proteinaceous coating present before the cleaning, completely disappear after the treatment. Another example of the use of portable FTIR to evaluate the removal efficacy of a cleaning treatment is reported in this slide, where the spectra obtained before and after the application of PHB biodiesel gel was applied on Donatello pulpit to remove a coating of wax. And as you can see, the band related to the wax substances disappear after the cleaning. Portable FTIR has the advantage to be portable and non-destructive, but since the spectra are acquired in reflection mode, the spectra are distorted, and sometimes the signal related to the organic substance may be of low intensity. So when you are testing at the very beginning the new cleaning system, it may be extremely useful from analytical point of view to test the cleaning methods on MOCKUP and to evaluate the removal efficacy by using FTIR, but in ATR mode. ATR mode foresees the use of a crystal that it is put in contact with the surface of the sample you are analyzing, and a pressure between the crystal and the surface is needed to obtain intense spectra. So this approach cannot be used directly on real work of art, but it is extremely useful on MOCKUP because you can directly put on the stage of your microscope the MOCKUP before and after the treatment and acquire several points to evaluate the efficacy of the methods. In this example, we compare the efficacy of different cleaning methods, normal PHB gel and the composite material, which are spectra B and C, to remove a dammer varnish from a glue painting. And as you can see, the band of the dammer resin disappear completely in the spectra acquired after the treatment with the composite material, while some residue remain when the normal gel is applied. So very good spectra are obtained with this way, which are not distorted, and a good evaluation of the efficacy of the treatment can be obtained. Another very important information that it is necessary to evaluate the efficacy of a cleaning treatment is the presence of residues, which can come from the supporting material, but also from the presence of the solvent if it is not too much volatile. So again, this information can be achieved directly on the work of art with a portable system or on the MOCKUPs, also using the FTIR system. And as an example, the previous application I've shown show that with the normal PHB GVL gel, not the composite system, residues of the solvent remain onto the surface, showing that the composite material has a more controlled release of the solvent. Another example on the presence of residues, in this case I show you what happened when we tested the agar gel with the deep eutectic solvents. Deep eutectic solvents are polar systems which are not volatile. So after their application on the MOCKUP performing ATR-FTIR spectroscopy, we can see the presence of residues of the solvent in this spectrum. So we have developed a two-treatment step. The first step is the application of the gel that allows to remove the proteinaceous coating, and then a second treatment which lasts just a few seconds with another gel containing an alcohol capable to remove the DES residues. And with ATR-FTIR spectroscopy, it is possible to observe the disappearance of the band related to the deep eutectic solvent after the second step of the treatment. Another important issue that has to be evaluated is not just the presence of the solvent on the surface of the work of art, but also its penetration inside the painting. To this extent, two different analytical approaches can be used. One is SPME, solid phase macro extraction, coupled with gas chromatography mass spectroscopy. This is a micro-distracted approach, so it can be mainly proposed for testing the new cleaning system on MOCKUPs. You need to take a small fragment to close it in a vial and to extract the solvents which evaporate with a fiber that is directly desorbed into the gas chromatographic system. And in this way, you can compare the performance of different methods we develop a procedure. We take 2 samples after 2 hours and 24 hours from the treatments, and we evaluate the percentage of solvent normalized for the weight of the sample released by the fragment. In this slide, you can show how the composite system show a lower uptake of solvent with respect to normal gel, showing a more controlled release of solvent. Another very interesting approach to evaluate the penetration of the solvent is microsource, spatially offset Raman spectroscopy. This system is based on Raman spectroscopy, but increasing the distance between the objective and the sample, it is possible to obtain information from a deeper layer and to observe the variation of the composition through the sample. By observing the variation of a signal related to the solvent with respect to a signal related to the painting layer, it is possible to understand how the solvent penetrates inside the sample. In this example, we tested the penetration of the hypothetical solvent inside an egg tempera painting after treating the surface either with directly the solvent on cotton swab or applying the gel. And you can see how the concentration of the solvent with respect to the band 404, which is related to the ochre present in the binder, is not so variable when the gel is applied and is a lower ratio with respect to the application directly of the solvent with cotton swab. Another very important information is related to the morphological modification of the surface, and this can be achieved using different types of techniques, such as optical coherent tomography, and we developed this approach in collaboration with Professor Piotr Targowski in the frame of a thesis of one of the SCORE students, Katerina Zaggia. This approach is extremely interesting because it allows to evaluate how the superficial morphology of the painting change after the application of the cleaning treatment, but used just on mock-up, because to better compare the situation before and after the cleaning treatment, the mock-up should be anchored to the system. However, the information that this technique is capable to produce is very interesting because it is possible to evaluate if the cleaning system produces over-cleaning or swelling of the layer. I don't go too much in deep on this because I see that I have not much time, so I will go on with the other example. The morphology of the surface after the treatment can be also evaluated using laser scanning 3D microprofilometry. This approach can be directly used on real objects. In this example, the effect of the application of a GVL PHB gel on a Cimabue painting is observed, showing that after the treatment, the surface doesn't appear uniform, so there are not variations in their morphology. It is possible also to obtain information of the mechanical property of the painting layer. Yes, this is possible with NMR reflectography. We tested this approach in collaboration with Professor Blumich's research group, and quite interesting information has been obtained. In this example, the comparison between the effect of pure solvent or a PHB gel with this green solvent is compared. Let's see which kind of information can be achieved. In this first graphic, the effect of the treatment with ethyl lactate on the painting layer is observed. The solvent is applied just by swab. You can see that the relaxation time, which are measured at constant depth on the mockup, has a wide distribution. These relaxation time are registered in step of time of 6-10 minutes. And you can see that in the first minute there is a wide distribution due to the fact that the painting layer contains a lot of solvents. Then the relaxation time starts to be more uniform due to the process of evaporation of the solvent and diffusion. But we can notice big changes in the first time due to probably a completely structural reordering of the binder. The signal related to low relaxation time are referred to the binder in the painting layer. The signal related to the either relaxation time are related to the solvent. Comparing what happens when the gel is applied, a completely graphic is obtained. The distribution is more ordered, and even if also the level of the lower relaxation time, with the passing of the time, one can see a linear decreasing. This is the proof that a general embrittlement of the painting layer occurs. A different behavior is observed when another solvent, DMC, is employed either as a pure solvent or as a gel. And in particular, when it is applied as a gel, you can see that the relaxation time remain more strict and constant with the passing of the time, meaning that the mechanical property of the painting layer are not affected. So this is a proof that this kind of gel has less effect on the painting layer than the previous one. So in conclusion, we can obtain several information by applying non-destructive and micro-destructive techniques in an integrated way. Some techniques are micro-destructive but provide some advantages in terms of the quality of information that they can provide. So this type of approach are advisable to be applied directly on mockups when the cleaning methods is to be tested and compared with other systems. Some other techniques provide less information, but they do not require the taking sample and can be used as a monitoring system when an already tested procedure is applied on a real case study. I thank you for your attention. And I let the floor to my colleague, Giorgia Sciutto.
Good morning to all. I'm going to share my screen so you can see now. You can see the
yes, we can see. Just
okay.
put it in.
Okay, so as anticipated by Sylvia, my part of the lecture will be mainly focused on, of course, advanced spectroscopies, but also on data processing methods, which are very important. And I'm going to try to explain you why. So, for studying artworks and, for instance, for study paintings, we have to, as we know, we have to apply different type of analytical technique that can be both non-invasive or microinvasive techniques. And there can be different type of analytical system that can be applied, like multispectral imaging, hyperspectral imaging, or even a single point analysis. Among them, probably the most powerful one is the hyperspectral imaging system. Why? Because this type of system, this type of method, allow us to obtain a very high level and a high number of information, due to the fact that we are using a lot of data and variable, and in the same time, this type of system allows us also to have information on the spatial distribution of components, so where and what and where. The data that we can obtain from this type of techniques are so-called hypercube or data cube, that is composed, which is represented like a cube, and is composed by spatial dimension information and spectral dimension. So for each pixel, for instance, we could have and we could extract a spectrum, and with together also the spatial information and coordinates related to that. So this type of techniques, as we said, it is really powerful and important, and it is, let me say, quite applied also in our field, but there is some drawbacks, let me say, because we obtain usually complex data. Why we obtain complex data? First of all, because we analyze a complex system. As we said, as you know, a painting, it is very complex system. Moreover, made by the mixture of different type of substances. Moreover, we have also to consider some problem related to the data. I mean, for instance, the spectrum that we record could present several deformation, or could have a low signal to noise, ratio. So that means that the interpretation, the evaluation of that data could be not so easy. Moreover, we have to also always to consider that spectra are number. So that means that we could visualize spectra like that, or even like that. So I like actually this image because always remind me a very crucial point, a very important aspect, that is that data is not the same as information, okay? Are data different from information? So even if this could be a representation of our first reaction in front of very complex data, there is a good news, because the data is not the same as information, but they contains information for sure. So the point is how to extract information from data. To do that, we could use two different types of approaches, let me say, under very general point of view, that are both correct: univariate approaches or multivariate approaches. The univariate approaches is probably the most simple method that just consider one variable in a spectra, for instance, is just a specific absorption bands at the time. The drawbacks related to this type of approach is mainly refer that this type of method doesn't consider the correlation of among all the variable and their effect that the different variable can have. So that's why it is usually important to use multivariate approaches, which is a way, let me say, more similar to, for work, more similar to how our brain, for instance, are working. And to do that, for instance, one discipline that is well known and could give us this type of opportunity to apply multivariate approach is chemometric. And I'm sure that all of you already heard about multivariate analysis, chemometrics, and so on. This is a nice graph that reports the number of papers each year per year during the time. The first work related to the multivariate analysis for cultural heritage has been published in 1998, and we can see how the number of papers increase sensible during the time. So that means that this type of approaches and field, it is quite fascinating, let me say, also for us. But there is a problem also in that point, because usually and sometimes the multivariate tools and analysis are not so available or accessible, and often not trained, not expert operators approach this type of method. That means also that we could have a very complex tool that cannot be properly applied, and even the result that we obtain from that analysis could be very difficult to be evaluated and interpreted. So that's why, and it is really a very crucial and important point nowadays for all the conservation scientists to consider that for us it is not only important to record data, for sure this is the first step, but we have also to think about the data interpretation. And so we are called also to develop new analytical method and system in order to offer simple tools for the evaluation of data that help also the correct implementation of hyperspectral system, for instance, in the diagnostic analytical protocols. According to that, I'm going to show you just an example or our work on it. We are working for some years concerning the development of new chemometric method. In that case, we have the opportunity to use and to work on data acquired on a very new and a pretty new system developed by Bruker, which allow, and it's called IRIS, and it is a system, an imaging system, hyperspectral imaging system that allow to record, to obtain data simultaneously with three different types of spectrum range. So for the XRF, NIR-SWIR and visible range. So that means that for each pixel we could obtain three different types of spectra. We decided to apply this type of system on a standard sample that had been prepared by our PhD student, Diego Quintero, which is based on the application of different paint layer. And as you can see here, all the areas present a specific stratigraphy. And this was important to evaluate the performances of the new instrument as well as the performances of our chemometric protocol to be for this task. So this is the general process that we applied for the evaluation and the data processing of that type of data. And I will now going to explain you the point a bit more in detail. So first of all, we have to think about data preprocessing, that is mainly referred just to the signal pretreatment, which allow us to reduce the systematic effect or random noise, and that allows us to reduce the dimension of the data. Then, due to the fact that we have a lot of data and we obtain with this instrument, for instance, 3 different types of data cube for the X-ray fluorescence, visible range, and near-SWIR range. However, as we said, we don't want to consider them separately, but put all together in order to enhance the type of information that we could achieve. So that's why we have to apply a data fusion approach. The data fusion method can be applied with different methodologies, probably the low, the mid, or the high level fusion. Probably the low or the mid data fusion are the most widely applied. For the low level fusion, we just have to concatenate our cube, just attach together, let me say. And the mid level fusion, we have to first perform the PCA on each cube and then to fuse the output obtained. However, we work with a low level fusion. So then we apply the principal component analysis. Also in that case, I'm sure that you already heard and maybe you already work with this type of technique, but just to remind you why it is so important, and probably is the most famous approach in our field under the multivariate method, because it is an explorative method. So that means that we don't need any information and any knowledge, prior knowledge to our data, and allow us to reduce the dimension of our data set while preserving the information. And the principle of the principal component analysis is that information is where is variance. Okay, so this helps us to see similarities or differences among spectra, and under, of course, a chemical point of view. PCA can be applied on a simple matrix of data like that, in which we have different type of spectra, for instance, or even can be applied on our data cube. How? Just by unfolding process. That means that it could give us the opportunity to, starting from our cube, to open the cube, let me say, to extract the spatial information and just to use the original data. In that case, we could perform easily principal component analysis, and on the output that are score values for each PG and for each pixel, we could then reconstruct, refolding our cube, and reconstruct our image by using a color scale, for the value of the score for each PG, obtaining a score maps. And this is the first color chemical maps, which that help us to evaluate areas that are, for instance, similar or different, and to then understand better why. Then, after once we have applied the PCA, considering the fact that our goal was, of course, to see the data, to fuse and to reduce the data, that huge amount of data, the point was also to see the correlation among variables, because this is also a very important point. So we decided to use very easy and simple tools, which is the correlation coefficient, by using 2 different types of tools, the correlation maps and the correlation diagrams. Sorry. The correlation maps, in that case, can be calculated by the computation of the correlation coefficient for each variable. So that means that for each energy with each wavelength, we could calculate the correlation coefficient. And we could code it, the result, with a chromatic scale. That means, for instance, that if 2 variables have a positive correlation. So when vary one, the second one change again in the same direction, they could have a red color. Why, if there is no correlation, they assume the green color, or if there is a negative correlation, so the change is in the opposite direction, they could have a blue color. This is important to see and to evaluate correlation among different spectral regions. But it is also important to evaluate correlation within the same spectrum. How to do that? Always use the correlation coefficient, but in that case, for instance, we could select a specific emission band, in the case of X-ray fluorescence spectra, and to see if it is correlated or not, and how, to the other peaks that are present in the spectrum. The same that can be done with the visible and the near range. So concerning a bit about the results, first of all, as we said, we perform principal component analysis to obtain score maps. And then what we can see it is that according to the chemical composition, there is a lot of information on different areas that can be visualized, and also to see some particulars that are not visible in the original picture of the painting, like here, like a star. If we want to go a bit more deep in that point, we could use a brushing approach, which allow us to select a specific area directly from the score map, or even from the score plot, in which are plotted all the pixels of our image. For instance, in that case, we decide to select that area, which is referred to the higher number of pixels concentrated here, and is referred to the background, okay, of our image. And then we could directly extract the average spectra just from that area. And we can see all the information that can be obtained from the different spectrum. For instance, there is zinc, and there is titanium and calcium for the X-ray, and for the near range, it is possible to see that there is, together with gypsum, that is always visible in the SWIR range, we could see also the presence of both fatty material and proteinaceous-based material. So, to apply the correlation, we decide to just focus our attention on that area. So we have to mask that area and to extract, to consider just that part, and then to apply the correlation results. For instance, in that case, we saw that if we are going to select the zinc for evaluation of the correlation within only the X-ray spectra, we saw that zinc show a negative correlation with titanium and calcium. What's mean? That means that probably there is or a very homogeneous system, or that there is some different layers, some different materials. But most probably zinc and titanium are not in the same on the same mixture. And of course, if we select titanium, show a negative correlation with zinc. Negative correlation, that means that when zinc is changing and vary, titanium also change, but in the positive direction, in opposite direction. So going to a bit more deep to see also our correlation maps, it is interesting to see that zinc is positive, have a positive correlation with the fatty material, okay, while present a negative correlation with the band that was previously visible, mainly related to the proteinaceous one, like collagen. Okay, so that means that probably these two organic fractions are not correlated as well, while if we consider the titanium area and peaks, we can see exactly the opposite situation. That means that the titanium is not correlated, it is negative correlated to the proteinaceous fatty material, while is positive correlated to the proteinaceous and collagen bands. So these remind us and help us to have several comments and consideration about the results that are mainly focused on the fact that possibly we could have a very different mixture or possible two different type of layers. In that case, it was easier for us, let me say, because we prepared the sample and we exactly know that there was two different layers. The first one was made by titanium white, and the second one was based on zinc white mixed with different binder. The titanium white was mixed with glue, while the zinc was mixed with HAG. That's why it was correlated to the fatty material fraction. So to conclude, I want just to remind you and to underline that even if nowadays we have a lot of system and very powerful method and instrument available for the analytical investigation of artworks, we have also to consider that it is not only the single part, but it is just a step. And we have also to pay attention and to study more the data analysis approach in order to offer new tools also for non-traded operator that can apply this type of tools and could extract the important information from that. And thank you for your attention.
Great, ladies.